Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. In that module 2, I have already completed 2 port networks. In the Laplace transform also, we are left with only one topic, last and final topic, that is the basic theorems of Laplace transform. We will see that in this video. In Laplace transform, in the previous video I have already done with the Laplace transformation and some of the sums related to that. Today in this video, basic theorems we will discuss. By this the module 2 will be completed. First basic theorem is shifting theorem. Shifting theorem is nothing but in any of the function we can shift the function by t naught, or how much ever, by 1 unit or 2 units or 3 units, n units, we can shift to right or left. So shifting theorem is nothing but if Laplace transform of f of t is equals to f of s, then L of f of t minus t naught, u of t minus t naught, means in the place of f of t, we are taking the shifting function, that is t minus t naught, like nothing but t is equals to t naught. Shifting we are taking as a t naught. So t minus t naught, so it will become t minus t naught equals to t minus t naught equals to 0. So we can take this as function f of t minus t naught. So f of t minus t naught into u of t minus t naught, that is equals to exponential, we can write exponential minus t naught s into f of s. This is the equation what we get. If we do f of t minus t naught into u of t minus t naught, you will get as exponential minus t naught s into, sorry, it is minus t naught e power minus t naught s in downwards s f of s. So we can write in this form. How can we do that? That there is a proof for it. Proof how we do is L of f of t, L of is nothing but Laplace transform of f of t minus t naught, u of t minus t naught is equals to integration 0 to infinity. We know that the f of t function need to be written and into e power minus st according to Laplace transform formula. T minus t naught, u of t minus t naught, e power minus st dt. If you see here, this u of t minus t naught we can remove by taking the integral t naught to infinity. So we can remove this u of t minus t naught to infinity will take the integral values, then you will get f of t minus t naught into e power minus st dt. So integral 0 to infinity f of tau exponential of minus s into tau plus t naught. What they have done here is, in the place of t, they have to t plus tau plus t naught. In the place of t, substitute tau plus t naught. In the place of t, if you substitute tau plus t naught get cancelled, you will get f of t tau. Here you will get exponential minus s of tau plus t naught into d tau. As all the t terms we are converting into d tau, so it is d tau. After writing till here, then what we will do is we'll write here minus s of t tau plus t naught. Then if you can take this exponential minus t naught into s. Why? Because outside. Why? Because tau is, it is with respect to tau only, d tau. So integration should be done only the tau terms. So f of tau into exponential minus t tau d tau is equals to, you can write as exponential minus t naught s into, this is nothing but f of s. If you see, this is in the form of f of s. That is this is the Laplace transform of f of s, that is nothing but integral 0 to infinity f of tau exponential minus s of tau, we can write of capital F of s. So where f of t minus t naught into u of t minus t naught is 0 when t is less than t naught. Then if it is t is greater than t naught, then it will be f of t minus t naught. Understanding? If t is less than t naught, Then f of t minus t tau here as my f of t minus t naught into u of t minus t naught will be 0. If it is t greater than t naught, it will be f of t minus t naught. So t minus t naught, if you take it as tau, and t will become tau plus t naught, dt will become d tau. Okay. So with limits t is equals to t naught implies tau is equals to 0. If you take tau is equals to 0, we can write t is equals to t naught. So t is equals to infinity implies tau is equals to infinity. Okay, if t is infinity implies tau is infinity. Therefore, Laplace transform of f of t minus t naught into u of t minus t naught is equals to exponential minus t naught into s into f of s. This is the final equation what we got. Okay, this is the final equation itself. Initially we got, but they're going there in these equations. They're explaining how when it will be 0, when t is less than t naught, what will be the value, when t is greater than t naught, what will be the value, and what are these values, and how t is equals to t naught can be done. When tau is equals to 0, it is nothing but t is equals to t naught. But the final proof what we want is this, and this is the equation we have, we have proved. Differentiation theorem. What is differentiation theorem? Differentiation, as the name tells, it is differentiation theorem. If you see, if a function f of t and its derivative are both Laplace transformable, if f of t and its derivative are both Laplace transformable, what they are telling, if the function f of t and its derivation is transformable, and if Laplace transform of f of t is equals to f of s, you know that Laplace transform of f of t is f of s, then the Laplace transform of the first derivative of a time function f of t is s times the Laplace transform of f of t minus the limit of f of t as t tends to 0. Nothing. The differentiation theorem states that there is a chance of in question paper asking to state the differentiation theorem and do the proof, give the proof, explain the proof. So better know these proofs and practice them. See what they are telling. If function f of t and its derivative are both transformable, they are both transformable means, then if Laplace transform of f of t is equals to f of s, then Laplace transform of first derivative of time function f of t. The Laplace transform of first derivative of f of t is s times the Laplace transform of f of t minus the limit of f of t as t tends to 0. So Laplace transform of first derivative of f of t is nothing but s in times the Laplace transform of f of t, that is s into f of s minus f of 0 plus, that is t tends to 0. Understanding? So how this comes? We'll see the proof. By definition, f of s is what? Is equal to Laplace transform of f of t. We know f of t, Laplace transform of f of t is integral 0 to infinity f of t to e power minus st dt. Integrating by parts, we get, we can write u is equals to f of t and du is equals to nothing but what happens, d by dt of f of t. We are taking differentiation to this, d by dt of f of t dt. Okay, so then if we take a dv is equals to e power minus st dt, then v will become 1 by s into e power minus st. Understanding? dv is equals to e power st they are taking. If you differentiate this, then you will get v is equals to e power minus st. We want b. Here dv is taken as e power minus st. So v will become what? This d differentiation coming this side becomes integration. Integration of e power minus st into dt it becomes. So what you get? Integration of e power minus st is nothing but e power minus st by minus s. So nothing but what? v will be equals to 1 by s into e power minus 1 by s into e power minus st. Understanding? Then after writing this, what will do? Hence, as 0 to infinity u dv is equals to uv. This formula you should know. In maths, this formula is already known, but I will tell you. See, if there is some function like this, integral 0 to infinity u into dv form, then what we need to do? First, write u value, then v from 0 to infinity minus integration 0 to infinity v du. dv is nothing but differentiation of v, or if you want v, then integration need to be done. So uv 0 to infinity minus integral 0 to infinity v du. dv already we found. For dv we get v as what? 1 by s into e power minus st. So v will become 1 by s into e power minus st. So in the limits of 0 to infinity minus 0 to infinity v du. You will write v first, the value of v, and du. Du value you got d by dt of f of t dt. Understanding? Nothing. If we need to bring the form in the form like u into dv, integral 0 to infinity u dv is the formula that uv into uv 0 to infinity. The v value what you got, that need to be not integrated, the limits need to be applied 0 to infinity minus integral 0 to infinity. The value of v need to be written into du value need to be substituted. This is the formula you need to remember. Then, so f of s is equals to minus 1 by s f of t e power minus st. Why? Because if you substitute these all values, you will get that 1 minus 1 by s e power minus st f of t 0 to infinity plus 1 by s integral 0 to infinity d by dt of f of t e power minus st dt. By substituting these values in this equation, you are getting this. After getting this, what you can write here, that f of 0 plus by s, f of 0 plus by s plus 1 by s Laplace transform of d by dt of t can be written. So, by this you can say that Laplace transform of d by dt of f of t is equals to s into f of s minus f of 0 plus. Just remember the theorem. You need to write and practice, then only you will understand. The main thing is the theorem. Okay. This needs to be remembered. Okay. Then. So this the same can be written for the n values also. See, s of n power f of s minus s of n minus 1 into f of 0 plus minus s of n minus 2 into f dash of 0 plus, so on you can write until the last. The same thing is explained here. So this is not required. So this much is enough. What is this? We can write this till n forms. N values we can write. Integration theorem. What is integration theorem? If Laplace transform f of t is equals to f of s, then the Laplace transform of the first integral of a function f of t with respect to time t is the Laplace transform of f of t divided by s. What they are telling? Laplace transform of integral 0 to t f of t dt will be equals to f of s by s. This is the theorem states. So how to prove this now? By definition, you know that L into f of, it is given what, 0 to t f of t dt. You will take the LHS side one, that is equals to 0 to infinity 0 to t f of t dt e power minus st dt. Nothing but you are taking this as f of t. So we are integrating this f of t to integral 0 to infinity e power minus st dt. Nothing but you are writing the Laplace transform. After writing the Laplace transform, if you see, you need to consider u is equals to, by parts you need to find again, like the one for the differentiation. U, if you see, is the 0 to t f of t dt. So du will become f of t dt. Why? Because this integration, if you want du, so integration and differentiation will be cancelled. Here the integration comes. Sorry, here differentiation comes. Du will become, here also differentiation, here also differentiation. So differentiation, integration cancels. So du is equals to f of t dt. After writing that, we want dv. how to write dv now? Dv is nothing but e power minus st dt. So b is equals to minus 1 by s e power minus st. You got these values. After that, you need to take the same way like the previous formula. After writing that formula, you need to substitute these values u and dv as well as v wherever required. Then apply the limits. Then you will get lastly as f of s by s. Okay, so we have proved f of s by s as the integration theorem of Laplace transform of 0 to t f of t dt. Okay, in general, for the nth order of integration, for nth order, same like differentiation theorem, we can write for nth order also. Then this nth order also. Then differentiation by s in complex frequency domain corresponds to multiplication by t in the time domain. That is, if Laplace transform of t f t is equals to minus d by ds of f of s. This is very important formula or the equation we use in sums. So you need to remember this equation. Prove the definition d by ds of f of s is equal to 0 to infinity f of t into d by ds e power minus st dt. That is equals to, you will get minus Laplace transform of t into f of t. So this can be written as Laplace transform of t into f of t is equals to minus d by ds of f of s. So you need to remember this formula. This is very important. Laplace transform of t into f of t is equals to minus d by ds of f of s. This is important. Initial value theorem. Initial value theorem states that if the Laplace transform of f of t is f of s and the first derivative of f of t is Laplace transformable, then initial value of f of t is, initial value means what? F of 0 plus is equals to Laplace transform of, not Laplace transform, limit t tends to 0 plus f of t. So we are tending t tends to 0 plus in initial value theorem. That is nothing but f of 0 plus, that is equals to limit s tends to infinity s into f of s is the Laplace transform of the in Laplace transform, it is the initial value theorem. Initial value theorem, what it states, f of 0 plus is equals to limit t tends to 0 plus f of t means is equals to limit s tends to infinity. In terms of frequency domain, in terms of time domain, in limit t tends to 0 plus f of t. In terms of frequency domain, it is Laplace transform domain. Laplace limit s tends to infinity, s into f of s need to be written for the initial value theorem. Then if the limit exists, then we get, we'll see the proof. Laplace transform of d by dt of f of t is equals to, what we need to write is f of t. So we'll write f of t into e power minus st dt and take integration. Nothing but Laplace transform we are taking. Nothing but s into f of s minus f of 0 plus. You already know this because in previous topic also this proof is done. S into f of s minus f of 0 plus. Now let s approaches infinity. Now s approaches infinity. Why? Because the formula states s approaches infinity. When s approaches infinity, then integral 0 to infinity d by dt of f of t power minus st dt, nothing but limit s tends to infinity. This e power 0 will become 1. Then you will get s of f of s minus f of 0 plus. S is not a function of t. So, by hypothesis, d by dt of f of t being Laplace transformable, the integral on the left side of the last equation exists. Therefore, it is allowable to s infinity before integrating. Then, left hand side vanishes. So, the left hand side vanishes. So, limit s tends to infinity, s into f of s minus f of 0 plus will be there. This left side equation vanishes and becomes 0 according to this. So, f of 0 plus will become limit s tends to infinity s of s. Why? Because if you take this f of s, f of 0 plus this side, then you will get limit s tends to infinity s into f of s. So, this is what you require. This is what you require and this is what you got it. Understanding? The initial value theorem is useful in determining the initial value of f of t and its derivative. We can find the initial value as well as the derivative. Next we have final value theorem. In final value theorem, if the Laplace transform of f of t is f of s, and if s into f of s is analytic on the imaginary axis and in the right half of the s plane, then limit s tends to infinity f of t is equals to limit s tends to infinity s into f of s. Okay, in initial value theorem, here t tends to, it was what, 0, but here limit s tends to infinity f of t, limit s tends to infinity s into f of s. By definition, you know that you can write this equation like the previous. Let s approaches to 0, then what we need to do, let s tends to 0, 0 to infinity, d by dt of f of t exponential minus st dt. Then you will get this equation, limit s tends to 0, s into f of s minus f of 0 plus. So limit t tends to infinity, f of t minus f of 0 plus is equals to limit s tends to infinity, f of x minus f of 0 plus. You can write in this way. So limit t tends to infinity, f of t is equals to limit s tends to 0, s of f of plus. This f of 0 plus f of 0 plus cancel. So you will get this equation. Actually this is not s, this is t. Just make it a correction that here it should be actually t. If this is frequency domain, this is time domain. No, this is frequency domain, this is time domain. In time domain it is t. So when t tends to infinity for final value theorem, t tends to infinity, s tends to infinity for frequency domain. So keep that in mind. So finally we've proved the final value theorem also. Now we will see some problems on this basic theorem. Example, find L of t square f of t using relation L of t into f of t minus g by ds of f of s. As I told you, this equation is very important. This equation is very important. L of t of nothing but Laplace transform of t of f of t is equal to minus d by ds of f of s. We have already proved. Using this relation, they are telling us to find Laplace transform of t square f of t. We know t f of t Laplace transform, we need to find d square f of t. It's very simple. Laplace transform of t f of t is equal to, we know that, minus d by dx of f of s by this equation. Then t square f of t will become what? Minus d by dx of Laplace transform of t into f of t. Am I right? F of s is what? Laplace transform of t into f of t. We need to write minus d by dx of Laplace transform of t into f of t. So Laplace transform of, why only one t they are taking? Because see, initially it is t of f of t, you get as minus d by dx of f of s. Here you want t square f of t. There is an extra t present. So minus d by dx of Laplace transform of t into f of t we want. Okay, then Laplace transform of t square f of t is equal to minus d by ds of this t into f of t Laplace transform is what? Minus d by ds of f of s. So take minus d by ds of f of s. So Laplace transform of t square f of t is equals to minus minus get cancelled. So d square by ds square f of s. Nothing but you need to remember is Laplace transform of t into f of t is minus d by ds of f of s. Laplace transform of t square f of t is nothing but double differentiation, that is d square by ds square of f of s. Understanding? Here there is no minus sign, here there is minus sign. This is very important. This question is asked in the previous question paper. Find Laplace transform of t square sin omega t using the relation this. See, this looks similar, no? T square f of t, in the place of f of t sin omega t is there. That's it. In the place of f of t sin omega t is there. We will see how to do. Laplace transform of t square sin omega t is equals to Laplace transform of t f of t, you know it as minus d by ds of f of s. So Laplace transform of t square f of t is nothing but, we know that, double differentiation, nothing, d square by s square by t into sin omega t. T into sin omega t. Why only one t? Only one t is already taken. It is t square of t. So t sin omega t. So d by ds square of, no, this is not t. This is Laplace transform of sin omega t. F of s is what? Laplace transform of sin omega t. F of t here is sin omega t. No. So Laplace transform of sin omega t is what? We need to no. See, I'll repeat it once again just to see. You know that Laplace transform of t square f of t is what? Just now we have seen d square by ds square. Nothing but differentiation, double differentiation. D square by ds square. That is, and f of s is nothing but Laplace transform of f of t. What is f of t? Sin omega t. So sin omega t Laplace transform is what? We have already seen in this before previous video. The formula for sin omega t Laplace transform is omega by s square plus omega square. Understanding? Omega by s square plus omega square, or w by, not w, it is omega on y because it is frequency. Omega by s square plus omega square. So if you differentiate this, it is in the form of u by v. Differentiation in terms of u by v is 2 omega s by v, differentiation of u by v. Okay, but if you see here, it is with respect to s only, so no need to take u by v. Why? Because the omega is not with respect, it is not mentioned in the d by ds, so omega is a constant here. It only with respect to ds, with the terms of s only will need to be differentiated. So d by ds square of omega by s square plus omega square is, you get as 2s, 2s, omega is present here, omega by s square plus omega square whole square. Understanding how? See, d by dx of 1 by x is nothing but minus 1 by x square. So in the place, the x place we have as s square plus omega square. So what we need to write? So minus 1 by s square plus omega square whole square. After doing this, we are again left with s square plus omega square. We need to differentiate again this. While differentiating, you will get as 2s. We are left with omega in the numerator. So we get 2 omega s by s square plus omega square whole square. Again we need to differentiate this again. Now you should take by u by v formula. Why? Because both numerator and denominator has the s. So we need to first consider v, then the differentiation of u minus u into differentiation of v by v square need to be done. I hope you know this, in already will be studied in the PUC, but again I am saying, see, u by v formula is v into differentiation of u minus u into differentiation of v by v square. If you do, you will get the equation what I am highlighting now. After that, if you see, we can cancel some of the things. Then you will get as 2 omega into s square minus omega square by 3 s square plus omega square whole cube. Given f of t is equal to e power minus st, whose transform is f of s is equal to 1 by s plus a. Find Laplace transform of t into e power minus st. You know that Laplace transform of e power minus st is 1 by s plus a. So they've already given that. We need to find Laplace transform of t into e power st. F of t is e power minus st. Laplace transform of t into f of t is nothing but, you know that, minus d by ds of f of s. So Laplace transform of t into e power minus st is equals to minus d by ds of Laplace transform of f of t is what here? E power minus t into f of t. No, f of t is what? E power minus st. Laplace transform of e power minus st is what? 1 by s plus a t into Laplace transform of t into e power minus st, that is equals to minus, you will get Laplace transform of 1 e power minus st is 1 by s plus a. After writing this, you need to take differentiation. Differentiation of this is what? D by dx of 1 by x is minus 1 by s square. That is nothing but minus 1 by s plus a whole square. So you get minus 1 by s plus a whole square. So directly I have written here. This minus is initially there. So write that minus as it is. Then you will get Laplace transform of t into e power minus st as 1 by s plus a whole square. Similarly, Laplace transform, if it is t power n into e power minus at. In question, if they ask in exam that Laplace transform of t into e power n plus at or st, then what we can do? N factorial. The factorial of this n by the x plus a by n power n s power a whole power n plus 1. So same, if you see this also, t into e power minus st. So 1 factorial by s plus a 1 plus n plus 1. So you get 2. So 1 by s plus a whole square. You can verify using the formula. It's easy. Understanding? I have written this similarly because if in exam they asked if it is for t power n, then this formula, if you know directly, you can solve the sum as it is, how I have done now, and you can verify with this formula whether it is correct or no. Find Laplace transform of sin omega t by t using the relation Laplace transform of f of t by t is equal to s to infinity f of s ds. Laplace transform of f of t by t is equals to integral s to infinity f of s ds. This you have already seen in the integration theorem. So f of t is nothing but what here, sin omega t. Laplace transform of sin omega t by t is equal to integral s to infinity Laplace transform of f of s is nothing but Laplace transform of f of t. F of t is what? Sin omega t. So Laplace transform of sin omega t ds. So Laplace transform of sin omega t by t is equals to s tends to integral s to infinity. You know the sin omega t is nothing but omega by s square plus omega square ds. Then if you see, since d by dx of tan inverse x is 1 by x square. You need to know these formulas, okay? D by dx of tan inverse x is 1 by 1 plus x square. So tan inverse x will become what? Integral 1 by x square. So in the same way, limit sin omega t by t is equals to, you can take omega common in the downside. So what happens is, if you take omega common, you will get s square by omega square plus 1 into omega square. This omega get cancelled. So you can write from this if you can see, in the place of x we are having what? S by omega. If you see in the place of x, if you put s by omega whole square, you will get the same thing, omega square by omega square plus s square by omega square. If you do this also, you will get the omega by s square plus omega square back. So you can easily put in the place of 1 by 1 plus x square, integration is tan inverse x. So integration of this is in the form of that only. So we can write tan inverse of s by omega. Here x is what? S by omega. Here x is what? S by omega. So integration s to infinity need to be taken. Then if you take, you will get tan inverse of infinity. You know infinity is tan pi by 2 is infinity. Then tan inverse of s by omega. So tan inverse and tan get cancelled. Then you get pi by 2 minus tan inverse of s by omega. Since tan inverse of 1 by x minus pi by 2 minus tan inverse x. Since tan inverse 1 by x is nothing but what? Pi by 2 minus tan inverse x. So here x is what? S by omega. So what it means? Tan inverse of minus tan inverse of 1 by x is equals to pi by 2 minus tan inverse x. So pi by 2 minus tan inverse x, pi by 2 minus tan inverse x is what? S by omega. So what we can write? Tan inverse of 1 by x. Tan inverse of 1 by x is what? X is what? S by omega. 1 by x means we should do ulta, S by omega to omega s. So you will get tan inverse of omega s as the value. This is little bit complicated. You need to do the formulas of which you have studied in QC. So please go back with the small formulas like d by dx of tan inverse x. Just remember. So you can do this you can do this sum. You need to find apply final value theorem and find the value of f of s that is equal to 5 by s into s square plus s plus 2. You know that limit t tends to infinity, f of t is equal to Laplace limit s tends to infinity, s into f of s is the final value theorem. If it is initial value theorem, t will tends to 0. If, as it is final value theorem, it is infinity. So you get this, that is equals to limit s tends to infinity, s into f of s. You know that f of s as 5 by s into s square plus s plus 2, s plus 2. So you know that s tends to infinity. as this is 5 s into s, this s and this s cancels, you'll get 5 by s square plus s plus 2. If you put s is equals to infinity in these two places, you are left with f by we are left with 5 by 2. So this is the value. Here s is here s is not written, so please write it is s into f of s. F of s is given, you need to write s into f of s. This s and this s get cancelled, so you will get 5 by s square plus s plus 2. S tends to infinity, so you will be left with 5 by 2. So now we are done with Laplace transformation and the basic theorems also. By this we completed module 2 successfully with all the videos with both the topics of the module 2. See, we have done with two-port networks, all the topics, and Laplace transform with all both the topics. So from the next video, I am going to start with the module 3, that is control systems. Till module 2, module 1 and module 2 is network analysis, and module 3 is control systems. In the next videos, I'll come up with the control systems videos. Please stay tuned. By this, I'm stopping this video. Thank you. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.